So hi children, in that previous video we discussed about that commutative property, right? So in this video we are going to discuss about that associative property. So what is that? Associative property. Associative property under natural numbers, whole numbers, integers, okay, rational numbers and real numbers. So we will see that associative property. So what about that? What is the definition of that associative property? If you group them, if you take that any three numbers, let A, B, C are any three numbers, if you group them in any way, then you will get the same result, then that type of number will satisfy that given property. Okay, then that property satisfied by that given number or that given type of numbers. Okay, so how it will be say? Let here we have to see that three numbers. Let A, B, C are any three numbers. Any three numbers. Then here we have to check that group them. Group them means A star B star C is equals to A star B star C. Here we have to check that three numbers, no? So here group them means here I am going to keep that brackets. Grouping means nothing but keeping a bracket. Okay, so here I am grouping that A and B. Here I have to keep that B and C. Okay, I have to group that B and C. So for that natural numbers under addition. So first we will discuss about that addition. Again just like that commutative property only. So under addition, how we can apply that? A plus B plus C brackets of which is equals to A plus brackets of B plus C. So already we know that if you add that any numbers, if you add that any number in, if you change the order means that is commutative property. If you change that, if you group them in any way, here there is no change in its order. You have to observe that thing. Here there is no change in its order. Here A, B, C, A, B, C. As it is there, how it is there in that LHS, as it is there in that RHS. Okay, so here there is no change in its order, just there is a change in its just grouping. Grouping means we have to keep that brackets. We have to apply that brackets. First I taking that group as A and B. In that RHS I kept that brackets for that B and C. Okay, so that is associative property. Okay, that is the definition. Now we have to check that in that all type of numbers it is satisfying or not. So I am going to take that here A is equals to 2, B is equals to 3 plus C is equals to 4. Now we have to take the same values now without changing. So 2 plus brackets of 3 plus 4. So when you observe that LHS, here first we have to take that addition of 2 and 3. So 2 plus 3 is equals to 5, 5 plus 4 which is equals to, here 2 as it is you have to write, plus here we have to add that 3 and 4. So 3 plus 4 is equals to 7. Just observe that up to here we are having two different numbers till we didn't take that resultant. Okay, just we added in different manner. Now here at last what about the result we have to observe. So 5 plus 4 is equals to 9 which is equals to 7 plus 2 also value is equals to 9. So in this case we are getting that the same values or not. Okay, same values only. Now what value there in that LHS, the same value should be there in that RHS also, no? So that's why here natural numbers are associative under addition. Okay, this condition satisfying, no? Okay, that's why here natural numbers are associative under addition. So natural numbers are satisfying. So is there satisfaction in that whole numbers or not? Automatically it will be satisfied. Why? Because if you take that as 0, any one of the number as 0, then for example 2 plus 0 plus 4. So 0 plus 4 is equals to 4, 4 plus 2 is equals to 6. So at the place of 3 I taken 0, no? So 2 plus 0 is equals to 2, 2 plus 4 is equals to 6. Okay, so if you apply that as 0, then also you will get that same resultant only. Okay, that's why here whole number satisfied. Whole number satisfied, so as well as What is that? Integers also satisfy, no? But I will show you that is it satisfying or not. In in integers, a plus b plus c, which is equals to a plus b plus c. In any way we can add that, okay? In the reverse order, LHS, RHS we can change, but here don't change the order, okay? So first one here I am going to take it as a minus 2 plus of minus 3 plus of minus 4, okay? So these values I taken here negative values. So a is equals to minus 2 plus of minus 3 plus of c is equals to minus 4. C is equals to minus 4. So here minus 2 plus of minus 3 plus into minus is equals to minus 4, which is equals to minus 2 plus into minus is equals to minus 3. Okay, again plus into minus is equals to minus 4. So here you will get the same resultant in the LHS and RHS or not, just we have to check. So minus 2 plus of minus 3 minus 4, that is minus 7, which is equals to minus 2 minus 3, that is minus 5, and here minus 4. So which is equals to minus 2 plus into minus is equals to minus 7, which is equals to minus 5 minus 4. So here minus 2 minus 7 is equals to minus 9, which is equals to minus 5 minus 4 is equals to minus 9. So here also you are getting that same values in both RHS and LHS, no? Yes or no? So that's why in integers also it satisfies. So integers also associative under addition. So these three satisfies, automatically rational numbers and real numbers also will be satisfied. Okay, you have to take that examples for that rational numbers and real numbers and try that. Okay, try it yourself. So next one is subtraction. Okay, under subtraction, for that natural numbers, what is the condition? A minus b minus c, which is equals to a minus of b minus c. A minus of b minus c. At the place of star we have to apply that we have to apply that fundamental operation, no? So like this way you will get. So here I am going to take that a is equals to 5, b is equals to 3 and c is equals to 4. 5, 3, 4. So here a is equals to 5 minus of b is equals to 3 and here c is equals to minus 4. Okay, so in this case how you will get 5 minus 3, that is equals to 2 minus 4, and here which is equals to 5 minus of here 3 minus 4, which is equals to minus 1. So 2 minus 4, which is equals to minus 2, and here 5 minus into minus is equals to plus 1, so which is equals to 6. So in this case also we can say that minus 2 not equals to 6. Okay, here LHS value not equals to RHS. By seeing only we can say that. So here under subtraction it will not be satisfied in any type of numbers. Okay, so here I proven for that natural numbers, no? You take that examples for that whole numbers, integers, rational numbers and real numbers and check for that also. So in these all cases also it will not be satisfied. In that all cases also it will not be satisfied. Okay. Next one is multiplication. Okay, under multiplication we have to check natural numbers. So here a into b into c, which is equals to a into b into c. Okay, so here a is equals to 2, b is equals to 3 and c is equals to 4. Apply the same numbers here. 2 into 3 into 4. Okay, so 2, 3, 6 into 4. which is equals to 2 into 3 fourths 12. So here 6 fourths 24, which is equals to 2 twelfths 24. So here we can say that LHS value is equals to RHS value. So under that natural numbers, it is satisfying. So natural numbers are associative under multiplication. Associative under multiplication. Come to that whole numbers. Take that any one number as 0. Here consider it as A is equals to 0 and B is equals to 3, C is equals to 4. So here 0 into 3 is equals to 0, 0 into 4 is equals to 0. Yes or no? 0 into 3 is equals to 0 into 4 is equals to 0 only you will get no. So apply here 0, then also you will get that 0. In that both cases you will get the same resultant or not. So if you apply that whole number means mostly you will conclude that 0 only no. Why? Because remaining all numbers are natural numbers no. That's why I am saying that 0. So in that all cases also it will be satisfies. If you take that any negative integers, come to that type of integers. Okay, here if you take that any two integers or three integers, okay, three positive integers, two negative integers, one positive integer, anyway you can take. Okay, if you apply that one here, in always you will get that satisfaction only. Okay, so here how we can say that natural numbers are associative under multiplication, as well as whole numbers are associative under multiplication, integers also associative under multiplication, and here rational numbers also satisfies that or associative under multiplication, and real numbers are also associative under multiplication. So addition and multiplication also satisfies here. Okay, so subtraction not possible, division is it possible? Automatically it will not be satisfied. Okay, wherever is equal to symbol is there means for the division and subtraction answers will be changed. Okay, so for the division easily we can write. So here I will tell you that condition. So come to under that natural numbers, what is the condition? A divided by B divided by C is equals to A divided by B divided by C. Let us see one example. Here 2 divided by 3 divided by 6, which is equals to 2 divided by 3 divided by 6. Okay, see that example here. So 2 by 3 whole by 6. Yes or no? That one only no meaning here. So 2 by 3 by 6. So 3 ones, 3 twos. So this one we can write it as 2 by 3 into, here we can write it as 6 by 1 also no. So its reciprocal become as 1 by 6, which is equals to 2 whole by 1 by 2. So it should be become as into 2 by 1. So which is equals to 2. Okay. So here 2 ones, 2 threes, which is equals to 1 by 3 threes 9, and here 4. Is 1 by 9 value equals to 4? 1 by 9 value should not be equals to 4. Okay, that's what I told you here. In division, in all cases, it will not be satisfied. Okay, so how we can say that? Associative property satisfies for under addition and multiplication only, for that all types of numbers. So which fundamental operations does not satisfy means subtraction and division. Mostly does not satisfy means subtraction and division only. Okay, satisfying means in each and every type of number and each and every type of property. Okay, which fundamental operation satisfies means addition and multiplication only. Okay, so this is about that associative property. Okay, so associative property under that addition, subtraction, multiplication and division related to that all types of numbers. Okay, so in that next video we will discuss about that next identity properties, inverse properties and distributive property. Okay.